Hi all. In this video, we'll be learning chapter 7, lesson 1, which is about factors and greatest common factors. Now, this is going to be a video for both your practice workbook answers as well as the explanation. Alongside doing solving the homework answers, I will also be explaining side by side what are the concepts in this lesson. So, as the name suggests, this lesson has factors. You need to learn about the factors and about greatest common factors. Now, to start with, this is a very important thing you need to carry throughout this chapter, which is about prime number. Hopefully by this stage many of you know what are prime numbers. Still, let's quickly revise them. So a prime number is a whole number that has exactly two positive factors, and I think everyone is aware of this word factors. Factors are nothing but the two numbers which we multiply. For example, if you're multiplying 6 multiplied by say, okay, for example, say the factors of 6. Okay, how do we get 6 when we multiply? Like which two numbers multiplied gives us 6? So one is 1 multiplied by 6 gives you 6, and the other is 2 multiplied by 3 gives you a 6, right? So 1 is a factor, 6 is a factor, 2 is a factor, and 3 is also a factor for 6. These are factors. So a prime number, it has only two positive factors as two positive factors. So how do you know whether it's a number, a prime number or not? For example, take number 5. What are the factors for number 5? It's only 1 multiplied by 5, because there is no other multiplied number which we multiply, we could get a 5. So 5 is called a prime number because it has 1 and the number itself as factors. So this is a factor and this is also a factor. So any number which has 1 and the number itself as factors are called as prime numbers. Now, for example, 6 cannot be a prime number because it has four factors. It has 1, it has 6, which is 1 and 6 itself. But 2 and 3 are also 2 and 3 are also factors. But 6 cannot be a prime number. But 7 can be, because the factors for 7 are 1 multiplied by 7, because there is no other multiplication which will give you a 7. So 1 and 7. So 1 is a factor and 7 itself is a factor. So a prime number has 1 and itself as a factor. So hopefully this is clear for you about prime numbers and factors. So let me show you how to find the prime factorization of 60. Okay, now there are two methods which you could use. The first one is called the factor tree method, and the other one is called the ladder diagram. Now, what is this factor tree? You will be like, now let me do it side by side. So I will explain you as well as I will show you the answers for the homework also. So here they have said write the prime factorization of 60. So let me show you the factor tree. So we start with 60. In fact, we go on dividing the 60 like a tree. That's why it's called a factor tree. So which two factors will give me 60? So there are not only one factors, there are many. Like for 60 we can say 1 multiply 60, but 1 we do not take because we have to divide that again. So starting from 2, you can say 2 multiply 30 is 60, then 3 multiply 20 is 60, 5 multiply 12 is 60. There are many factors for 60, right? So let me take it as 2 multiplied by 30. You can take any number you want to. Finally, anyhow, once you do the prime factorization, your answer is going to be the same no matter which factors you choose. So here I have chosen 2 and 30. Now, 2 is a prime number. Okay, 2 is a prime number because 1 and 2 are the factors. So I do not do anything for 2. Rather, I'm going to keep on dividing 30 until I get the prime numbers. So 30 can be again divided in two parts as 5 and 6, or 2 and 15, 3 and 10. It's totally up to you. I am choosing 5 and 6. Now again check. Is 5 a prime number? Yes, it is a prime number. So I do not do anything for 5. Rather, 6 is not a prime number. I'm dividing 6 again in two parts. So what gives me 6? 2 multiply 3 gives me 6, or 6 multiply 1 gives me 6, but it doesn't make sense if I choose 6 once, because again I need to keep dividing 6. So I choose 2 multiply by 3. Never choose the factors which have 1 and the number itself. Okay, never choose them for prime factorization. So 6 can be again 2 and 3. So is 2 a prime number? Yes. Is 3 a prime number? Yes. So once you reach, once you get all of them as prime numbers, you just stop there. So this is how you factorize using a factor tree. So all what you need to do is arrange them in the order. So 2 multiplied by 2 multiplied by 3 multiplied by 5. Okay, this is how you write the prime factorization, which means when you multiply, you should get 60. So do a quick check. 2 2s are 4, 4 3s are 12, 12 5s are 60. So you got a 60. Let me show you the ladder diagram. Now, why do you call it a ladder diagram? Because it goes like a ladder. You start from the smallest possible number which you could divide this. So that's a 2. So 60 divided by 2 gives me a 30. Then again divide 30 by any number. So better it to be a prime number. So this will give me a 15. So again divide it, because 15 is not a 15 can be still divided by 3. So 3 5 will give me 15. Then again finally I will divide it with 5, because 5 is a prime number. So again, to arrange it, I'm going to write it in that order. 2 multiplied by 2 multiplied by 3 multiplied by 5. No matter which factors you choose, except 1 and the number itself, any other factor you choose, finally when you finish prime factorization, your prime factorization is going to be the same, whether you use the factor tree or the ladder diagram. So it's totally up to you which method you want to choose. Now, after the prime factorization, let's see how can we write this using the exponential form. So now you know that we have two 2's, which means I can write it in exponent form as 2 to the power of 2, because there are two 2's. Then multiplied by 3 multiplied by 5. This is how you use exponential form to write the prime factorization. Hopefully that part is clear for you. So let me quickly work out through these. Now if you have not done the homework, this is a good chance for you to do the homework along with the video. If you have done the homework, then you can check your answers. Fine, let's do the prime factorization for 18, 120 and 56. Now I'll show you 3 each, how to do using the ladder method and also the tree method, so that you will be familiar with both the ways. So for this 3, I'll use the ladder method. So even if you would have used the tree, the factor tree method, your answer will be the same. Right, so let's start with 18. So the smallest possible factor to divide it is 2, which will give me a 9. Now, which is the smallest possible factor which I could divide 9 with? A 3. This is going to give me a 3. So again, I'm going to divide it until I'll keep dividing it until I get the remainder here as 1. So 3 divided by 3 gives you 1. So the prime factorization of 18 is going to be 2 multiplied by 3 multiplied by 3. Now using the exponential form, it's going to be 2 multiplied by 3 to the power of 2. Now, even if you would have used the tree method, the factor tree method, your answer is going to be the same. Right, let's check for 120. Okay, so 120, the smallest possible factor is going to be 2. So I divide that, that will give me a 60. Now I can divide this with 2 again, that will give me a 30. Now 30 still can be divided with 2, so that will give me a 15. Now 15 cannot be divided by 2, so I choose another number which I could divide 15. So that's a 3, which means it's going to be a 5. Then again I divide this also with 5, that will give me a 1. So I keep dividing with the smallest possible factor until I get the answer as 1, until I get the remainder as 1. So let's rearrange this. It's 120 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 5. How am I going to write this using the exponential form? 2 to the power of 3, because I have 1, 2, 3 2's, multiplied by 3 multiplied by 5. For a quick check, just multiply them mentally, so you can 2 2's are 4, 4 2's are 8, 8 3's are 24, 24 5's are 120. Okay, similarly, let's do this. 56. So 56 divided by 2 is going, 2 is the smallest possible number. We could divide many numbers, right? So this is going to give me a 28. Again, I can divide 28 by 2. That will give me a 14. Again, I can divide 14 by 2. That will give me a 7. Now 7 can only be divided with 7, not with 3 or any other number. So this is going to give me a remainder of 2. If I would rearrange the factors of 56, that's going to give me 2 multiplied by 2 multiplied by 2 multiplied by 7. So written in exponential form, it's going to be 2 to the power of 3 multiplied by 7. Okay, so using the factor tree, you must get the same factorization as well. Okay, now question 4 to 6, I'm going to use the factor tree method because they are quite big numbers, right? So 390, I'm going to divide it in two parts, which might give me, which numbers if I multiplied would give me 390. So which numbers do you think? Now it's a 0, that means it can be divisible by 5 and it can be divisible by 2 or a 10. Okay, so let me take it as 10 and 39. These are the rules, divisibility rules. If it is a 0, it's a number is ending with a 0, you can either divide it with 2, with 5 or with 10. Okay, so further still I can divide this because they are not prime numbers. 10 is not a prime number. So 2 and 5. What about 39? 39 also can be divided again as 3 and 13. Now check once again, are they all prime numbers? Is 2 a prime number? Yes. Is 5 a prime number? Yes. Is 3 a prime number? Yes. And 13 is also a prime number. So the prime factorization for 390 is going to be 2 multiplied by 3, because it's always preferable to arrange it from least to greatest. Okay, so 2 multiplied by 3 multiplied by 5 multiplied by 13. Now we cannot write this in any exponential form because there are no numbers, factors which have been repeated. So this is going to be the prime factorization for 390. So 144. So what gives you 144? Which two factors will give you 144? Definitely it's going to be 12 and 12. Or you can even divide it as 2 multiplied by 72. It's totally up to you. Okay, so whatever it is, however, whichever factors you choose, the answer finally is going to be this, in this form, in the factorized form. So I have chosen here 12 and 12. I'm going to divide further 12 and 12 as 2 and 6. And for a change, let me do this as 3 and 4. You can also do it as 2 and 6, no problem. But just I want to show that this is also possible. That's why I'm doing it. Now 2 is a prime number, so I do not do anything for it. But 6 is not. So I further divide it again into 2 and 3. Then 3 is a prime number. I don't do anything, but I can still divide 4 as 2 and 2. So keep dividing until you get prime numbers. So let's rearrange these factors now. 144, how many 2's do we have? 1, 2, 3, 4. So we have 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3. Right? Now for a quick check, just keep multiplying them. 2 2's are 4, 4 2's are 8, 8 2's are 16, 16 3's are going to give you a 48, 48 3's are going to give you 144. Right, now that you have got the prime factors, you are just going to write it in exponential form. So how many 2's do we have? We have 4 2's. That means 2 to the power of 4 multiplied by 3. Now we also have 3 2's, which means it's going to be a 3 squared. So 2 to the power of 4 and multiplied by 3 squared. This is the prime factorization for 144. So 153. Now let me divide it as 351. How do I know which number to choose? Definitely, it's better you go through the rules of divisibility. If any number finishes with a 3, it can be divided with 3. Okay. So 3 is a prime number. I do not do anything. What about 51? Is 51 a prime number? Do you think 51 is a prime number? No, it's not. So we are again going to divide this into 2. So what is that going to give me? That's going to give me 3 multiplied by 17 is going to give me a 51. Okay, now 17 is a prime number, so we cannot do anything further than that. So 153, if we write the prime factorization, it's going to be 3 multiplied by 3 multiplied by 17, which means it's going to be 3 square multiplied by 17. Hopefully you must have got the answer right if you have done the homework. Right, let's move on with the lesson and find out the GCF. Now, GCF stands for greatest common factor. So we are going to find the common factors. Now that you know what are the factors, we are going to find the common factors between these two numbers that do the greatest common factor. Well, we are going to do the same, which is the prime factorization. Through prime factorization, we will find out what is the GCF of these two numbers, because if you do prime factorization, you can never go wrong. So if you have done well, that's good. If you have not understood, just I'll quickly take you through this question. So 16 and 20. So I have 16 and I have 20. Now, if you have done prime factorization, if you have a good knowledge of prime factorization, you can do this mentally. You don't need to draw the tree and find out. Let me show you how. Start with 2, because you know 2 is always a factor of 16, right? Which next number multiplied by 2 will give you something which is 16? So that's again a 2. 2 twos are 4, 4 twos are 8, 8 twos are 16. So you can even mentally do the prime factorization. If you cannot, then you have to draw the tree or the ladder and then find out. So for 20, the prime factorization is going to be 2 multiplied by 2 multiplied by 5, because 2 twos are 4, 4 fives are 20. So now here, which is the common factor for both of them? I've got a pair of 2 as common, another pair of 2 as common, and nothing else. There is no other common factor, right? So what you're going to do is, finally you need to say GCF is going to be, you will choose 1, 2 from here because we consider them as 1. Okay, so 1, 2 from here, another 2 from this factor pair, so that's going to give you 4. So the greatest common factor for 16 and 20 is going to be 4. It is as simple as that. Once you have perfected yourself in finding the prime factorization, doing the prime factorization, this becomes more easier. Let's try this. 9 and 36. Okay, so what is going to be the prime factor for 9? It's not going to be a 2 because there is no 9 in the table of 2. So it has to be 3. 3 threes are 9. Now for 36 as well, you can start with a 2. Okay, now let me show you that. Two 18s will give you a 36, then two 9s will give you a 18, and then 3 3. So which means 2, 2, 4, 3, 3. So let's start with 2. 2 multiplied by 2 gives you a 4. 4 multiplied 3 gives you a 12. 12 multiplied 3 gives you a 36. Now, what about the common factors? What are the common factors here we have? We have a pair of 3 common, and another pair of 3 also we have as common. So how do you find the GCF? The GCF is going to be, we take only one 3 from this pair and another 3 from this pair. Okay, so GCF is going to be 3 multiplied by 3, which is going to be 9. So the GCF of 9 and 36 is 9. So if you would practice this, immediately when you look at 9 and 36, you know that GCF is going to be 9, because 9 is 36 is also in the table of 9. So you will know that 9 is the greatest common factor. Right, let's go ahead and try some more. So we have to do the prime factorization for 15 and 28. So the prime factorization for 15 is going to be 3, 5. And for 28, it's going to be just now we did for 28, is that? I think in one of the questions we did. Okay, well, this is going to be 2 because there is 28 in the table of 2. So start from the smaller one. 2 multiplied by 2, which is going to give you a 4. Then 4 multiply what gives you 28? Definitely it's going to be 7. Now 7 is a prime number, so we can stop with that. Now what's common here? Can you find anything common? There is nothing common. So when there is nothing common, we say the GCF is going to be 1. Now, there's a point to be remembered. If there are no common factors after prime factorization, you say the GCF is 1. Okay, let's move on to the next one. This is going to be 35 and 42. So the prime factorization for 35 is going to be 5 multiplied by 7, because both of them are prime numbers, so there is no more other factorization for that. But for 42, we have 2 multiplied by, say, it's 3, right? Or we could say 2 multiplied by 2 is 4. Then 4 multiplied by, what else will give us? What about if I write another 2, that is going to be 8. So 8 multiply anything, does that give me 42? No. So I need to change the number here. So I could say 2 2s are 4, 4 3s are 12. Right? Now, does 12 multiplied by anything gives me 42? If you are stuck in a situation like that, the best thing is do the prime factorization. Okay, so this is going to give you 21, and this is going to give me 3 and 7, which means there is only 1 2. So if you ever come across, if you think you cannot do the way like orally or mentally, simply stick to this way. So this is going to give you 2 multiplied by 3 multiplied by 7. So which is the common factor here? Only common factor we have is 7. So the GCF is going to be 7. Never do like 7 multiplied by 7, because we consider this 2 sevens as one factor. Okay, so the GCF of this is going to be 7. Well, let's go to 33 and 66. So 33 and 66. So the prime factorization for 33 is going to be 3 multiplied by 11. And for 66, it's going to be a quite a longer one, because it starts with a 2. And then 2, what gives us 66? 233. So 33 again can be divided as 3 and 11, right? If I would show that in a prime fact, a tree, that's gonna be okay. You could even do 6 11, okay, which means 6 is not a prime number, so 2 3 2 3 11. Fine. So the the common factors are 3 and 11, so which means the GCF is going to be 3 multiplied by 11, which is going to give you 33. So the GCF, the greatest common factor, is going to be 33. Similarly, for this is an easy number, so this is going to be 2 multiplied by 2 multiplied by 5 multiplied by 5. Okay, and for 120, it's going to be 2. Well, let me do this because it's quite a big number. It's going to be 340, then 580 or 220. It's totally up to you. If I would choose a bigger number than 2, like factors than 2, it would quickly finish rather than 2 and 20 and then 20. So that's why I'm choosing the bigger factors. So this is going to be 2, 2. This is going to be 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 5. I did not write that in the order. So here we have a pair of 2 as common factors, another pair of 2 as common factors, and also I have 5 as common factor here. So GCF is going to be 2 multiplied by 2 multiplied by 5, which is going to give me a 20. So the GCF of 100 and 120 is going to be 20. This is how you find factors, the GCF of numbers. Now for this, I'm not going to do the steps, rather I would just give you the answer, because you do the answers. We have done enough questions now on how to find them. Okay, so for this, the GCF of 78 and 30 is going to be 6. Okay, if you do have any doubts, you could definitely ask. It's the same way which we have done already now, 6 questions. Okay, and the next one is going to be 42. So the prime factorization of this is going to be, the GCF of this is going to be 42. This is 6 and this is 42. Use the same way which we did this, and then definitely we'll get the GCF as 6 and 42. Right, let's go ahead and check this. Now you're going to find the GCF of monomials. Hopefully you remember what are monomials. Okay, so The same way we are going to do for these also, only that we have the values of x here with the exponents. So what do you do when we have questions like this? That is when you have to find the GCF for monomials. So first we have to find the prime factorization for the number. Okay, the prime factorization for 15. What do you think is the prime factorization for 15? For 15, the prime factorization is 3 multiplied by 5. Do not worry about this x. This x means it is x multiplied by x multiplied by x multiplied by x. Simply we are expanding the value of x, that's all. So x to the power of 4 means x has been multiplied 4 times. Similarly here, what is the prime number factorization for 35? 35, it's going to be 5 multiplied by 7, which means x squared, that's x multiplied by x. Now find the common factors here. We have 5 as the common factor. Also we have one pair of x as the common factor. Also we have another pair of x as common factors, which means GCF is going to be 5 multiplied by x multiplied by x. So this is going to give us x multiply x will give you a 5x squared. So the GCF of 15x to the power of 4 and 35x squared is going to be 5x squared. All what you need to do is find the prime factorization for the number and then expand the value of x. That's all. So what about this? 12p squared and 30 q to the power of 5. Now, what I'm going to do first, find the prime factorization for 12 and 30. So the prime factorization for 12 is going to be 2, 2, and 3. Well, I'm doing this mentally. Okay, if you are not aware of doing it mentally, you can do this. All right, 3, 2. So 2, 2, 3. Then for 30, it's going to be 2 multiplied by 3 multiplied by 5. 2 3s are 6, 6 5s are 30. So the common factors are going to be 2 and a pair of 3. So the GCF, then I forgot to write the P's here. So P here and here we have Q but 5 times. But that doesn't make any difference because there are no common variables. So there's nothing to take as common. So the GCF is just 2 multiplied by 3, which is going to give you a 6. That's all. Because P is different from Q, so you cannot take any common variable there, right? So 2 multiplied 3 is going to give you a 6. Right, let's move ahead and check this. Negative 60 cube and 90. Now do remember, a GCF can never be in negative numbers. A GCF can never be in negative numbers. Okay, so negative 60 cube. So negative 60 cube and 90. Well, the prime factorization for negative 6 can be 2 multiplied by negative 3, right? Multiplied by t, multiplied by t, multiplied by t. And for 9, it's going to be 3 multiplied by 3 multiplied by t. Because the prime factorization for 9 is going to be 3 multiplied 3. Now, what's common here? What do you think you could take as common numbers here? Definitely you have a 3, but it's different from 3. So what you could do is simply adjust it with negative 2, because negative 2 multiplied by 3 will also give you a negative 6. Not necessarily you have to only multiply 3 with negative, right? As you can see a pair of 3 as common factor here. So if it would have been negative 3, that means GCF is going to be a negative 1, which is not possible, right? So we have just shift the negative sign to the other number, that's all. So the GCF of this is going to be 3 multiplied by t, which is going to be a 3t. So the GCF of negative 60 cube and 9t is going to be 3t. Let's try this out. So we have 27 y cube z and 45 x square y. Okay, for 27, it's going to be 3 multiplied by 3 multiplied by 3. Okay, then you have y cube, which means y multiplied by y multiplied by y. Then we also have a z. So this is the expanded form of all that. So 45 is going to be 3 multiplied by 3 multiplied by 5. Because when you just imagine 45, the first factors which will come to your mind is 5 and 9. So 5 itself is a prime factor. So 9 will give you 3, 3. So that's how you do prime factorization mentally. So x we have is square, which means x multiplied by x, then we have a y. So the common factors we have is 3, one pair of 3, another pair of 3, and a pair of y, because there is no other common factor here. So the GCF is going to be 3. We take 1 3 as a common factor from this 2, and then another 3 from this as 1. I mean a common factor as 3. Then we take 1 y. So that's going to give us 3 3s are going to be 9. 9 multiplied y is going to give you 9y. So the GCF of 27y cubed z and 45x squared y is going to be 9y. Right, let's do this question quickly. This is an easy one. 12ab and 12. So 12ab means it's going to be 2 multiplied by 2 multiplied by 3 multiplied by a multiplied by b. So for this similarly, it's going to be the same. Okay, so the common factors are 2, 2, 3. But even if you look at it, you can see the common numbers. They are 12 and there's nothing else common. So the GCF is going to be 12, definitely. So 2 2s are 4, 4 3s are 12. So the GCF is going to be 12. Okay, now here we have a negative number, which means negative 8d to the power of cube and 14d to the power of 4. So negative 8 means definitely you know, like any one number has to be negative, right? So let me keep it as this, multiplied by d, multiplied by d, multiplied by d. Similarly for 14, we have 2 multiplied by 7 multiplied by d 4 times. So d multiplied d, d and d. So the common factors are 2, 2, right? So we just take 1, 2. And then how many d's can we remove here? 1, 2, and 3. So d multiply d multiply d multiply d, which means 2d cubed. This is how you find GCF of this two. Right, let's go to the next question. We are nearing it, nearing the end of it. So here you know that there is a coefficient of a negative 1, right? So that's going to be this is 3n to the power of 6 and n. So this means it's a negative 1 definitely, but then m will be multiplied 8 times. It's a quite long one. 4, 5, 6, 7, 8, and 8, 8, right? And then n 4 times, right? 1, 2, 3, and 4. And this multiply. Similarly for 3, now 3 itself is a prime number, so we cannot take anything except not even a negative 1, because it's a positive number. So let it be 3. We do not really care about that. Okay, then m is going to be multiplied 6 times and then n 1 time. Right, let's find the common factors. So here we have 1 pair of m, 2 pairs of m, 3 pairs of m, 4 pairs of m, 5, and then 6 pairs of m common and 1 pair of n common. So the GCF is going to be m to the power of 6 and n to the power of, n, no, only n, because it's just one pair. So n to the power of 6 with n. So if you would look at this here, okay, without doing all these steps, you could see that here we have 6 m's. So you could definitely remove, like from 8 you can remove 6. So m6 becomes common there. Here also you have 1 n here and 4 n. So even you can remove 1 n from here. But I don't want you to use that method because sometimes you might do a bit mistake in that. So better you follow this always. Right, so let's do the last one here. 10g, h cube, h square, and 5h. So I'll do it here. Now 10g h squared, that means 2 multiplied by 5 multiplied by g multiplied by h. And then 5h means 5 itself is a prime number, so 5 multiply h. I think you can find out the GCF now. GCF is going to be 5h. So this is going to be the GCF. Right, let's do the last problem solving here. Christine is decorating her bedroom wall with photographs. She has 36 photographs of family and 28 photographs of friends. She wants to arrange the photographs in rows so that each row has the same number of photographs, and photographs of family, photographs of friends do not appear in the same row. How many rows will be there if Kirsten puts the greatest possible number of photographs in each row? How many photographs will be in each row? So for this question, in fact, you need to just work backward. You need to start from B, because how many photographs will be in each row means you need to find the GCF here. Okay, once you find the GCF, then you can find out how many rows will be there. So kind of working backwards, right? Let's find the GCF of 36 and 28. This is going to be 2 multiplied 2, 4, 4, 3 multiplied 3. For 28, it's going to be 2 multiplied by 2 multiplied by 7. Okay, so the GCF is going to be 4. So how many photographs will be in each row? 4 photographs will be in each row. Okay, now here they're asking how many rows will be there. So she has 36 photographs of family and 32 photographs of friends. So which means if she's putting 36 photographs and in each row there are 4, that means for 36 photographs, it's going to be 9 rows, because 36 divided by 4 is going to give you 9 rows, right? So for family photographs, she will have 9 rows. What about the photographs of friends? 28 divided by 4, that's going to give you a 7. So that means it's going to be 7 rows. So 9 rows, and 9 rows for the family, 7 rows for the friends. So altogether, it's going to be 9 plus 7 rows, which is going to be 16 rows. So if how many rows will be there if she puts the greatest possible number? So the greatest possible number is 4. So if she would put 4 in each row, so she's going to have 16 rows. So this is how you need to solve this problem solving. Hopefully you have understood the lesson. If you have understood, do like the video. And if you have any doubt, definitely you can clear them with me. So till we meet in another video, keep practicing now.